Okay, so the next part of this question says, consider this function. N is greater than 1. Use your graphic display calculator to explore the graph of this function for odd values n equals 3 and n equals 5, and the even values n equals 2 and n equals 4, and then complete the following table. Okay, so this definitely, I want my calculator because I'm not too sure what's going on. So I'm going to get, and it actually says use your graphic display calculator. Now, I think I've said previously, guys, there are questions. These paper 3s are difficult, don't get me wrong, but the first few questions, the first few parts are usually, let's say, accessible to everyone. And this is one of those questions. This is definitely accessible for everyone because you just need to sketch it. So we're going to sketch x to the power of 3. So let's do this one first. We'll do the 3 and the 5. So x to the power of 3 times brackets 2 minus x to the power of 3 again, because n is 3, not 4, 3. And we get this. And maybe let's zoom in a little bit. Zoom in. Okay, not bad. Okay, so question. How many local maximums does it have? How many local minimums does it have? And how many, so we need the local minimums. Let me make this a bit smaller. We need the local number of local maximum points. There's 1. Number of local minimum points. There's 0. And number of points of inflection with 0 gradient. Okay, that's this one, guys, and this one. It has a 0 gradient there, and it has a 0 gradient there. What about the one for 5? Now, I'm assuming, because of the question, this is going to be the same. It's going to have the same answers, because in the table that we need to complete, there's only one space. So this, when I put in 5 here, I'm expecting 1 maximum, no minimums, and 2 points of inflection with 0 gradient. Let's have a look. Yeah, good. If there's that 1 maximum, there's no minimums, and there's these 2 points with 2 points of inflection. These are points of inflection where the concavity changes and the gradient is 0. So in here, I'm going to put the number of local maximum points is 1. The number of local minimum points is 0. And the number of, by the way, this is a 6-mark question, guys. This is worth 6 marks, and it's just basically 1 mark for each of these. Number of points of inflection with 0 gradient, 2. Now we just need to try for 2 and 4. Let's see what happens. Let's change this to, 1 second. Let's change this to 2. So for 2, we get 1 max, 2 mins, and there's no, I can zoom out, but I'm pretty sure these are, because this is essentially a quartic function, it's not going to change any bit up here and up here. So we basically have 1 max, 2 mins, and no points of inflection with 0 gradient. So let's write, well, let's just check the 5, but again, I'm hoping / assuming that that's going to be the same. Let's have a look. So I'll change this to 4, change this to 4, and this to 4, and yeah, there's my max, there's a min, and there's no point of inflection with 0 gradient. So 1 max, 2 mins, and 0 of these. 1 max, 2 mins, and 0 of those. Okay, not a bad 6 marks, guys, in my opinion. Okay, that's part B. I'll do part C in the next video.